to x square. These are equations and it can be represented by graphically. But it is not possible to represent all equations as graphically. That's why we use formula to solve for equation. That's why we use equations. About slope already you know. Positive, negative, constant. Constant which means 0 in the language of differentiation. If in our equation has a constant value or constant, for example 4, 5, 6, 7, then these are constants and we will represent it uh, by using constant, and we will say that yeah, value of this would be value of 4 would be otherwise you can say depreciation of 4 would be 0. Okay, this is a language of depreciation, and this will happen with a constant. This will happen with the constants. What is a depreciation? What is the meaning of this word? Meaning of this word is just a slope, just a slope. And might have, you must have heard about integration. Integration. It is just opposite process of depreciation, but our context is depreciation. I was, I wanted to say a word about integration. Our full focus will be on this, okay, on this depreciation. We will take some questions based on this. We will understand, we will break down, we will understand step by step what is the process of solving of a equation and the context of this. Okay. Now, if we understand simple meaning of this word, so meaning would be what? Slope. It is just a slope, and slope are a lot of types. But mainly, if we talk about mainly, then we will realize 3 or 4 or 5. That's it. This is enough to describe in this. Uh, what are those? Those are constant slope, positive slope, and negative slope. And it is very simple to describe this type of slope. Okay. For example, I ask you, what is the name of this slope? What is the name of this slope? This is also a slope. But what is the name of this slope? Which type of slope is there? You would say, most of you would say that it is a constant. It is a constant because line is parallel. Line is straight, not parallel. It is also parallel, but we should have two lines. Then we can say this is a parallel. So this is a straight. That's why we are saying what there is a no slope. There is a no slope. If we wanted to express, then we would say slope is 0. Slope, and there is a nothing slope. So 0, which means nothing. The slope is nothing in this case. Okay. So name of the slope is constant, and we will notice, we will observe uh, this type of slope in our equation. For example, 4, 5. These are what? Uh, no slope, which is constant. And you also can say this is a constant. This is constant. And say here number value of a variable is not a changing, of this slope. Instead, number of this is a constant. For example, 4, 5, 6. Fixed. Number of this is fixed. That's why we say constant. Now it's time to understand about positive slope. When we talk about a positive slope, then we say that from downward to upward we go. We have one object. It is just an example. It is just an example. We have one object, and one object is moving from one point, which is downward, from downward to upward. So downward to upward, it tells us that this is slope. This is slope of positive. This is a positive slope. So uh, hint of a positive slope is uh, from slope will go from downward to upward. Now just a pursuit. If slope is going from upward to downward, so we would say this is a negative slope. We would say this is a negative slope because of this slope came from upward to downward. That's why. Okay. Time up. How to represent? How to represent? To represent it, we use dy by dx. So it means rate of change in y variable will determine who our upon who is dt dy dx x. So change in y variable with respect to x variable with respect to x variable. If x, so who will decide? Who will determine? X will determine. X will decide what is changing in y variable. So who will decide? X will decide. Okay. If we go like this, so it is what x axis. So here we are talking about slope. If we are going downward, it is also x. We are as a x axis. Now, as we will move, then y will be considered with respect to x variable. For example, this is x axis. Now one object is here. As one object will move, then also y will move as well. So first of all, one object needs to move on x-axis. Then y will consider itself. Y will uh, move because of object, because object moved on x-axis. So here we are getting y curve because of x moved on object moved on x-axis. That's why we got y curve. So who will decide? Who will determine? X-axis. Object will move where? On x-axis, not y-axis. not a yx. Now we have equation. It is enough, I think so. It is enough. Now question. This is not question, but as a question, we will break down it. Can you tell me what is the solution of this? Let me explain. dy by dx. Then we have y, which is x. In place of y is x. In place of y is x. Okay. Now depreciation of x. Always remember this is just a formula. Okay. So remember that formula of depreciation of x would be 1. Would be how much? 1. Got it? Whenever, wherever you are noticing x, only x in equation of depreciation, then remember depreciation of x would be how much? 1. 1. Now next. So in place of y, we have x square. Now here we will apply a formula of depreciation for this equation. What is the formula? Formula is if x n which means natural numbers, counting numbers would be what? N. First of all, we will write n, then x value. Okay. Then we will subtract n. We will subtract 1 from n. Clear? Got it? This is just a formula. This is just a formula. And it will help a lot of times in solving questions based on differentiation. It will help, I am sure. Now, x and upward number is natural numbers. X or 2, 2, 2, 2. So first of we will write 2 because of formula. Formula is the same. Then just a variable. Now it's a time to subtract. We will subtract 1 from 2. We applied formula, this formula. Now we have to simplify it, which is it can be also written 2x because of 1 is hidden. 1 is hidden. I hope you understood it well better. Now I give you another question based on this question. What? Why is 16? Okay. How would you solve? First of all, exponent. You can also remember like that. Exponent. First of all, exponent will be written at first place 16. Then variable as it. Now 1 will be reduced from given exponents. Exponents. We applied here formula and we have to just simplify it. Till here, this is our answer. It is very simple. Now, y is equal to what if x 3 minus 3. Now you are looking, it is integers. It is integer. We can convert this equation is x raised to the power minus 3 into natural number. But still we can solve it. It is not very heavy. Still we can solve it. Just look. In place of y is x raised to the power minus 3. Now okay, we are going to differentiate to x raised to the power minus 3. It is very simple. Just as we know, first of all we will write exponents, which is minus 3. Then we have a variable, which is x. Now we will reduce 1 from given exponents. Got it? How much would be here? Minus 4. Minus 4. Till here, this is your answer. If you want to solve ahead or two, then you can write minus 3 as it, minus 3, and then x raised to the power minus 4, it can be written like that. This is also your answer. But just we converted this, we removed this hint, this operation into positive. And we didn't change our answer. You can see, answer is the same. Answer is the same. To change operation, addition, subtraction, multiplication, division, we change the position of variable or numbers. Okay, like that. Now let's return to another question. Y is equal to what is equal x raised to the power 2 by 3. How would you solve now it? How would you say? First of all, you will write here already. You will write. Now exponent. Exponent is where and how much? 2 by 3. Okay. Then variable has it. Now as we know, 1 will be reduced from given exponents. 2 by 3 minus 1 by 1. Now we have to simplify it. We have answer which is 2 upon 3 x raised to the power minus 1 by 3. Further of its can be written, can be solved. You can also write it can be further solved. But till here, this is enough for answer. Now, I think we should take next different question. And our next question is uh, we are moving on trigonometric differentiation. Trigonometric differentiation. Why is sin x? Why is sin x? It's very simple. Dy by d. Then in place of y is sin x. So depreciation of sin x would be formula would be cos x. Just opposite. Just opposite. That's it. So it can be remembered as a formula. It happens when equation is a sin x, then differentiation of sin x would be cos x. Now next, y is cos x, then answer of differentiation of a cos x would be something else. Something else. Uh, so in place of y is how much? Cos x. Now also remember we have cos. You can also remember that cos c is a letter, first letter, which is a hint of minus. So minus and opposite of cos x would be sin x. So depreciation of cos x is minus sin x. Okay. These are not questions, but these are formulas which will help to us in solving questions based on this. Okay. Now, y is e raised to the power x. There is a twist. There is a twist. What is a twist? In place of y is dx. dx. Now it is said that e raised to the power x differentiation of this Differentiation of its would be as it would be as it. There is a no chance of equation Ex. Okay. So in this case, we will observe that there is nothing change. There is nothing change. Now, why is log nx? Log nx. Otherwise, you can write ln x, ln x, ln x. Always remember differentiation of ln x is what 1 by x. 1 by x. It is just formula. It is just formula. Don't worry. Apart from like this formulas, I am going to take. I will take interesting questions. Remember, these are just formulas. Now, let's move on the rules of these rules. There are some rules which will obey, which will follow. So, first, if equations are in addition and multiplication, contents in multiplication and addition. For example, y is 2 sine x plus b 3. And we have another question. Now let's break down it as much as possible. What main point is, what is it saying? We were understanding about formulas of its. Now it's a time to understand rules of its. If equations are in multiplication and addition, we have equation which is y is equals to 2. Here 2 and with 2 is with sin x. So here we are looking at combination of combination of multiplication. Here there is a product, there is a multiplication. Then we can see here is what addition. Here there could be subtraction. Could be subtraction in this rule. Okay, always remember here could be subtraction. It is not a heavy part. Now we can observe that we have an equation which is in multiplication with addition. 2 is with sin x, which is in multiplication with 3. 3 which is with addition. Now, okay, we understood meaning of this. What is the way? What is the process? What is process to solve it? It is very simple. Divide dx. So it is the same. We are going to represent, that's why we use divide and dx, and it is saying that change of y variable is with respect to change in x. Okay, change in x variable. Uh, So here we have question, in place of y is this. So in place of y is 2 sin x plus 3 upon dx. So 2 will be as it. 2 will be as it. Okay. We want to represent product number. Product number 2. Okay. Then whatever we have two terms. First which is sin x and second which is 3. And both two terms will be written different. For example, sin x upon dx and then 3 upon x. Okay. Now it's a very simple. We are observing that differentiation of sin x is something cos x. Now I was teaching you that differentiation of if we have only number in our equation, then differentiation of a number will be 0 when we are doing differentiation. Then here it's a time to observe that we have number. Okay, we can write here 0. Here 0. So in the language of differentiation, what is the way to say that it would be 0? It says that constant, which are numbers, so differentiation of a constant would be 0, always be 0 in the case of this, in the language of this. So this is constant, would be 0. Now we have 2 cos x, which is the answer. And this is a type of equation we are looking, which is very interesting. Now we will fill what happened. Interesting. Now next. So here 2 we will write 2 separate. This is a product. Now first term, okay, upon x and dx, then second term. It means we will differentiate to x square, and here we will represent 3. 2 as it, because 2 is not in differentiation. So here x square 2x and then 0. 4x. This is answer. Understood? Next question. Next question. If no. Can you tell me what is the process? 6 as it. This is with the product x5 and then 16. We have 16. 6x raised to the power 5. So 5x power. Already you know. If x there is a xn, then differentiation of xn would be nx raised to the power n minus 1. Then 16, 0. 6 5s are 30. x4. Simple. Just have a look. Then I would like to move on. Next. 5 ln x plus 2 first, and then second y is equal to 1.24. Here dy by dx, and then 5 as it ln x. First of all, we write like this. Okay. 5 ln x, depreciation of ln x, and 0. 5 by x. So 5 as it, because of this is with the product, and depreciation of ln x as we discussed. So depreciation of ln x would be how much? 1 by x, and as we know already, our depreciation of a constant would be 0. Then we simplified answer, which is 5 by x. Now next dy upon dx. So this is with the product, it will be written as it. There is no change with the number which is with the product. Now we have two terms. Uh, you can see this is very complicated, but it is not as complicated as you are thinking. This will be written as a, okay, differentiation of a cos minus sin x. First of all, 1.24 upon 3, and then minus sin x, and then we have one day number, which depreciation of this would be 0. 0. Now let's simplify it. So here depreciation of a cos x, and then depreciation of a constant 0. Then we simplified it. It is so much easy. Now let's take next. Y ax plus b. Okay. Here a is with a is a number, and b is a number. Okay, a is a number and b is a number. Now a will be written as it, as we know, and we have now total. We have total, which is a x, and then this a as it, and the depreciation of ax would be simple as it, and depreciation of a constant would be 0. So answer is okay. I hope you got it. Now next, what if equation is 7 by 2 e x plus 9 by 16. Then how would you solve it? It is looking like it's a complicated. Don't worry. Just first, just take a first step. Just take first step. When you once you will complete first step, then think about next step and solve. Gradually, you will reach to the answer. So first step is this is now this is a product as it will be written as it we have okay. hmm We have just a question. So 7 by 2 as it and depreciation of EX would be as it. Now depreciation of a constant 0. 7 by 2 is it not very simple? Of course, I have one more question based on this. Okay, but I will give little complicated. Let's see what is why. For example, okay, first of all, we will take first step. Minus 16 by 9 will be written as it depreciation of AX. Clear? This is the first step, and it is very easy to take first step of any equation. Now it is as it because of this is not a depreciation. Now depreciation of AX as we know, it will be as it. Now this is 0 because of constant. This is constant. And finally answer is here we saw a tiny difference among this question. Tiny difference, not a hard difference, more difference. So shall we take next? Shall we take next? Next question. First is y AW cos x 0. Let me all question. Now we have three questions. It will be last for this rule. We can have more questions based on this rule, but just for practice, we have taken some questions based on it. Now, first of all, this A is what? A is a number. W is also number. W is also number. And cos x. Cos x. And the 0 is already constant. So AW will be written as it. Okay. So differentiation of cos x would be minus sin x. Minus sin x. Okay. It was very simple. It was very simple. Now can you solve it? And we solved it. We solved like that question just right now. Do you have any idea to solve it? Here, dy by dx clear, and in place of y is a x addition, then a 2. So we don't have number. As it, depreciation of x as it. But here we have a value of x which is 2. Now there is a value of a raised to the power x something something. But here we didn't have a given value of x, but here we have a given value of x. Value of x. That's why there is a value of this a2. So this is a constant. We will consider it as a constant because of there is a value of this. That's why. But I don't know clearly. I don't know. So we will behave it. We will consider it as a constant. Now this is also. This is also. Now this is. 2 as a this 2 is with a production a product depreciation of sin x, then depreciation of a pi. So 2 as a depreciation of a sin x would be cos x, and depreciation of a pi would be constant, would be 0. So value of a pi is what? 3 point, if we say in decimal, then would be 3.14444 something something. But in a rational number, the value of pi would be 22 by 7. So there is a value of pi in mathematics, which is number. That's why we considered it as a constant. Finally, we have ounce, which is 2 cos x. 2 cos x. We understood contents in multiplication, addition, and addition. Now it's a time to break down of next rules of its. We are done. We are completed one rule of its. It's a time to second rule. Just have a look. Now we have a lot of questions. Now we have a lot of questions. Just have a look at question. Here we have a four equation. We have four equations. We saw first rule of a differentiation. Now this is the second rule. Functions would be in addition or differentiation, in addition and subtraction, not multiplication. We saw multiplication function which are in multiplication with addition or subtraction. Now only addition and subtraction. And functions are in addition, subtraction, addition, subtraction, subtraction. No multiplication, no division. Only is addition, subtraction. Then it is a very too much interesting to solve it. How? We have we have whatever whatever terms. We have four terms or five terms. In this rule I'm talking about, in this rule we have four terms, five terms, for five terms, not times, terms, six terms, seven terms, 10, 20. Then we will do differentiation of all each terms. In this case we have 10 terms. Then we will do differentiate of all each terms. Okay. We have first term which is x square. X square. So first step is very easy. Okay, just we will write with the differentiation because of we are converting this equation in differentiation. That's why. Then we have sin x. Clear? Okay. Here x raised to the power n. What is the formula? N x raised to the power 1 will be reduced from exponent, from given exponent. So can we write 2x? Of course. We did write two exponents at first place. Then we wrote x by. Then we subtract 1 from given exponents, which is 1. Here you are not looking, here you are not saying 1 because 1 is a hidden. Now, sin x, where is cos x? Simple cos x. This is final answer. This is a final answer. It is a too much easy? Of course. Here we did notice what we have. We have two differentiation. Differentiation of x square and the differentiation of sin x. So here two differentiation because we had two terms. That's why. Two terms. Now here we can observe as well here what we have two equations. We can have three terms. We can have also four terms, five terms. So we don't need to be worried. Okay. Just we will write each term and differentiate 2x so here differentiation of x is what okay, then we have a cos x, then sin x minus a sin x, so we have 2 minus sin x. This is the answer. Got it? Now next we have three terms as you can see, 1 2 3, and we will do differentiate of each this given terms. How? So x square can be written to x and cos x and then 0. Finally 2x cos x, answer. Got it? That's it. Now fourth. 4 y, then x square, then ln x. ln x. Dear buddy, we have three terms. We have three terms. First, which is x3. Second, which is x2, and third, which is ln x. So x3 can be written 3x square and 2x and 1 by x. This is the final answer. This is the final answer. We converted this equation in differentiation equation. In differentiation equation. Got it? Just have a look for few seconds this question. Then I will move on the next. Now next. Next, can you solve it? Can you solve it? It is very simple, brother. First of all, here it can be written. You can also read it. We are converting this fraction, this rational number, into natural number. Into natural number. It can be written. Of course, yes. Now we are able to solve it easily. I did write each these terms with a differentiation, with a dy by dx. Now minus 2 and minus 3, okay. Then here minus 3, okay, minus 4, okay. Then here would be 0. Minus 2 and this minus 3 x square. Got it. Yeah, this is a final answer. Here we did write each this term with the differentiation. Then we did differentiate each this term. Then we wrote and then we simplified it. Next. This is equation. They have three terms, and we will write it as it. D ln x upon dx, then d ax upon x, then d cos x upon x. Okay. Now ln x can be written 1 by x and would be minus the sin x. 1x we will simplify it, then we will have got it. This is answer. Clear? Now functions are in multiplications. This is third rule. This is third rule. Functions are in multiplications. Multiplications. So let's take a first question. And second is x square ax. Now here we can see one term. We have how much? One term. We can say that here is two terms. One, two. But two terms are with multiplication. In this case, we will do how first variable we will write as it. We will write as it first variable as it. Okay. Now second variable we will do differentiate. We will do differentiate to next variable. Okay. Now we will write second variable as it. Got it? Now we will do differentiate of first value. Got it? Ah, okay. X is not in differentiation. That's why it will be written as it. Differentiation of a cos x, sin x is cos x. Sin x will be written as it because of this is not in differentiation. Uh, Differentiation of x would be 1. We have finally answered. Got it? So first variable we will write as it, and we will do differentiate of second variable, and then we will apply addition, because in the case of multiplication we use addition, and we will observe addition in the case of multiplication. But in the case of division, we will see what division, subtraction. So always we will observe when there is a multiplication field, then we will observe addition. But whereas there is a division field, then we will observe subtraction. Got it? Okay. Now, then we will write second variable as it, and now finally we will do differentiate of first variable. This is how we will solve of equation which are in multiplications. Now next, dy by dx. Okay, in place of y, here first variable as it, second variable is in differentiation. Yeah, then it will be as it. Okay, ex as it, ex as it, 2x. Okay, ex, then ex 2x. Here we can say a common ex. So we can put ex one time. 2x. This is a final answer. This is a final answer. Understood? So here step was first variable we will write as it, second variable we will do differentiate, then we will apply addition in the case of multiplications, then we will write second variable as it, and then we will do differentiate of first variable. That's it. Then we will apply formula, then we will simplify whatever we have in equation. Okay, I am going to take next. I am going to take next. Here, cos x, sin x, which are trigonometric. Now it's a time to solve trigonometric. Okay. We have trigonometric in multiplication. So let's do a differentiate it. A by x. Okay, sin x. No. First of all, first variable as it, and then cos x will be the differentiated. Then second variable will be written as it. Okay. Sin x as it, because of this is not in differentiation. Differentiation of cos x would be minus sin x. Then it as it and would be cos x. Now minus sin square x and then cos square x. Clear? Otherwise we can write this is 2 times. This is 2 times. Okay. So we can also write cos x square minus sin x square. Okay, this is final answer. This is a final answer. I hope you got it how to solve like that. Just we wrote a sin x as it because of this is the first variable, and the first variable in the case of a multiplication, in the case of a rule of multiplications, which are functions are in multiplication. So first variable will be written as it. We will not differentiate to first variable, and the second variable will be done differentiate. Then we will apply addition because of this is multiplication. Then second variable we will write as it, and then we will do differentiate of first variable. Then we will apply our formula. Then we will simplify. Then we will have finally answer. Now next. X square alien x square alien x. Wow. So can we write x square as it, then ln x. Okay, okay, okay. Then ln x and d x square dx. Till here, I hope you are already crystal clear. Aha, x square ln x 1 by x. Okay, as it and 2x. Here we are looking. Can we cut this? Now we have x plus ln x 2x. This is final answer. This is how we solve like that question. This is not heavy. This is not complicated. It doesn't look complicated. Complicate. Now we're done. We're done. We saw rules of first rule of depreciation, second rule, then third rule. This was the third rule, and we will do fourth rule, which would be function are in division. Then chain rule, chain rule. Then multiple differentiation of a equation. So whatever we have left, we will understand all left rules of its in another slide.